Hello, assalamu alaikum, all viewers and dear students. Today we have a new topic, additive inverse of complex number and multiplicative inverse of complex number. How we can derive it? Let's come. We start from the additive. How we can derive it? Let's come. We start from the additive inverse of complex number. Additive inverse of complex number. Let's we take any complex number that is denoted by z. Let z is equal to a plus iota b be any complex number. Then additive inverse means that we are taking the result becomes into zero. If we add two complex number, so the result becomes 0. So it means that here we take one of the z is equal to a plus iota b. Now we are taking here minus z is equal to minus into a plus iota b. So we can write this one minus a minus iota b. Now additive inverse means that if we add these two terms, so the result will be equal to what? It means that minus z. Here is minus z. So if we add that, so the result must be 0. So a plus iota b plus and minus z. Minus z automatically we get minus a minus iota b. Now if we add these two terms a plus iota b plus into minus minus a plus into minus minus iota b. Now real part to real. So it means that a minus a plus iota b. Imaginary part we add to imaginary part iota b minus iota b. Now look here, this will be cancelled, iota b is also cancelled, so we get the result 0. It means that the additive inverse of any two complex number must be 0. We can say that minus z is the additive inverse of a plus iota b. So multiplicative inverse of complex number z inverse, it means that we can write a plus iota b inverse. We can write here 1 by z is equal to 1 plus a plus iota b. Now automatically look here in the denominator is imaginary part is coming. So we try to finish this iota. What we will do, we have already discussed in the previous video. So it means that we are taking dividing and multiplying by the conjugate of dividing and multiplying by the conjugate of a plus iota b. So in conjugate we change the imaginary part sign. So here we get a minus b. It means this term we multiply and divide also a plus a iota b into a minus iota b and divide by a minus iota b. Non-denominator is multiply to each others. 1 multiplied by a we get a, 1 multiplied by minus iota b we get minus iota b. And here in the denominator we get formula a square minus b square. Means that a plus b into a minus b is equal to a square minus b square. Here we use this formula a square minus iota b whole square. Simplify this one further. A minus iota b, a square plus iota, sorry, minus iota square and b square. So we can write a minus iota b divided by a square. Here minus 1 iota square minus iota square, we know that minus 1. So we replace iota square, we put minus 1 b square. A minus iota b divided by a square minus minus plus b square. Now we arrange the real, separate real parts and imaginary parts. We can write a divided by a square plus b square minus iota b divided by a square plus b square. This part is called real part and this part is called imaginary part. So the multiplicative inverse of z is equal to a divided by a square plus b square minus iota b a square plus b square. So the result will be, this formula must be remembered, the multiplicative inverse of any complex number. So now we are exercise 1.2, question number 4, related with this topic and also very important for your future life. Dear student, this question is very important. Find the additive inverse and multiplicative inverse of question number part 1. 5 plus 2 iota. Look here. So the name of complex number is not given. So we take, first of all, we give the name of complex number. Let z is equal to plus 2 iota. Now we require the additive inverse. We are finding the solution of additive inverse. It means that here we require taking minus z, multiplying both sides by minus 1. Minus 1 we can also multiply on both sides of this one. So minus z is equal to minus 5 minus 2 iota. But in additive inverse, it means that we are adding minus z is equal to 5 plus 2 iota plus, in the place of minus z we get already minus 5 minus 2 iota. Now open the brackets. 5 plus 2 iota plus into minus minus 5 plus into minus minus 2 iota. So the result will be 5 minus 5 is 0, 2 iota positive and minus 2 iota both are cancelled. So the result will be 0. And already we discussed in the definition of additive complex number to complex number, if we add, so the result must be 0. Now we multiplicative inverse 1 by z is equal to 1 by 5 plus 2 iota. Now here in the denominator iota is a problem. So first of all we try to finish this iota. It means that we taking conjugate of this number and divide and also multiply by this one. Now 5 plus 2 iota, it means that 5 minus 2 iota is the conjugate, multiply and also divide. Now numerator is multiplied to each others. So 1, 1 multiplied by 5 minus iota, 5 minus 2 iota, and the denominator we use the formula a plus b, a minus b is equal to a square minus b square. So 5 square minus 2 iota whole square. Now expand this from 5 minus 2 iota, 25 minus 4, 2 square and 2 iota square. Iota square is equal to minus 1. Now we simplify this one. 5 minus 2 iota divided by 25 minus 4 iota minus 1. Now look here, 5 minus 2 iota, 25 minus minus plus 4. So we get the answer 29. 5 minus 2 iota, 5 minus 2 iota divided by 29. Now we separate the real part and imaginary part. 1 over z is equal to 1 over z is equal to 5 divided by 29 minus 2 iota divided by 29. This one is the real part, and 2 iota divided by 29 is imaginary part. This is the multiplicative inverse of z. Means that z inverse, we can also write this one z inverse 5 divided by 29 minus 2 divided by 29 iota, which is the form of a plus b iota. Also we can say that here a is called real part and b is called imaginary part. Question number 5. Let z1 is equal to 2 plus iota and z2 is equal to 1 minus 3 iota. Then prove that z1 plus z2 conjugate is equal to z1 conjugate plus z2 conjugate. Two complex number are given. Now we try to solve this one. Z1 plus Z2 whole conjugate is equal to Z1 conjugate plus Z2 conjugate. Now taking left hand side, we are taking left hand side. Consider the left hand side. Taking left hand side is equal to Z1 plus Z2 whole conjugate. Now it means that we cannot solve directly this one. First of all, we consider the term z1 plus z2. We add these two terms, then we take in conjugate. First of all, we add 2 plus iota plus 1 minus 3 iota. Real part will be add to the real part. 2 plus 1 plus iota. Here is iota and here is also iota. We can add this one, yeah, or we can write 1 minus 3 iota. So now we want 2 plus 1 3 plus iota minus 2 iota. Now it means that 3 minus 2 iota plus into minus 2 iota. Now this implies that here z1 plus z2 is, we get here 3 minus 2 iota. Now we are finding conjugate of this one, z1 plus z2 whole conjugate is equal to 3 minus 2 iota conjugate, and already we have discussed in the conjugate definitions we change the imaginary part of sign. Here symbol is minus, so we change into positive. 3 plus 2 iota. Left hand side is equal to 3 plus 2 iota. Now we are going here to take right hand side. We are checking both results are same or not. Because we are verify these two results, we prove that z1 plus z2 bar is equal to z1 bar individually plus z2 bar individually, both are equal or not. First of all, we consider the term z1 bar, then we first 2 plus iota conjugate, so it means that the positive sign change into minus 2 iota. Similarly, and z2a conjugate is equal to 1 minus 3 iota, so the sign is also changed here, 1 plus 3 iota. Now we are going to make, this implies that z1 bar plus z2 bar is equal to 2 minus iota plus 1 plus 3 iota. Now real part, add to the real part, we can write 2 plus 1 plus minus iota plus 3 iota. Now look here, we get here 3 and minus iota plus 3 iota, we get plus 2 iota. So now comparing, now give equation number 1 and equation number 2. Now comparing equation number 1, now comparing equation number first and second, both results are equal, so left hand side is equal to right hand side. Both results are equal. 2 plus is equal to 3 plus 2 iota. It means that Z1 bar complete, Z1 bar plus Z2 whole conjugate is equal to Z bar, Z1 bar and Z2 bar individually. Both results are equal. Equal to 2 plus 3 iota. Second part of the same question, and 2 minus 3 iota. Now verify that Z1 and Z2 is equal to Z1 conjugate and Z2 conjugate. Now we want to prove this result. Both results are same or not. Taking left hand side is equal to Z1, Z2 complete individually. So we cannot directly multiply these two terms. First of all, we consider the term Z1 and Z2. First of all, we multiply these two terms. Then after the product of these two terms we find, then we take the conjugate. Now substitute the values 2 plus 3 iota into 2 minus 3 iota. Now look here, we can directly use here formula a plus b and a minus b because the a term both are same. Here is a are same. Similarly, b and b are both are same. That means that we can use here a plus b and to a minus b is equal to a square minus b square. If this formula is not remembered, we can also another method we can use multiply to each other. So here use the formula 2 square minus 3 iota whole square. So the result is 4 minus 3 square into iota square. Iota square we know that this will be 9. Iota square we know that minus 1. So the result is 4 into plus 1 this one plus 9 plus 9 the result is 13. That means that 13 we can write 13 plus 0 iota in the form of a plus iota b. Now we are taking here the conjugate of this one, taking conjugate Z1, Z2 conjugate is equal to 13 plus 0 iota. It means that if we take the conjugate 13 minus 0 iota, it means that we get 13. So the result of left hand side is equal to 13. Similarly, now we want to right hand side. Coming to the right hand side, Z1 conjugate and 2 Z2 conjugate, and individually consider the term we write. Consider the term Z1 bar is equal to 2 plus 3 iota conjugate, so we can write 2 minus 3 iota. The sign is changed here into negative. Similarly, Z2 bar is equal to 2 minus 3 iota, so the conjugate, so sign is changed into positive 2 plus 3 iota. Now, but the required term is Z1 and 2 Z2 conjugate, both are multiplied to each other. So it means that 2 minus 3 iota and 2 plus 3 iota. Similarly, the same term we use here, this one, look here, we directly use the formula 2 square minus 3 iota whole square. So we get here 4 minus 3 square iota square. So 4 minus 9 into minus 1. So the result is minus into minus plus 9. So the result is 13. 13 we can write 13 plus 0 iota. So it means that if we take checking both results, this one, so the result is 13. Comparing the both results, so left hand side is equal to the right hand side. For any complex number, show that Z1 and Z2 conjugate absolute as equal. Absolute and Z2 absolute for any complex number. So we are taking supposition question number 6. Question number 6, the same exercise 1.2. We try to solve this question. Now, first of all, we take any complex number z1 and z2 are any two complex number. Suppose that z1 is the first complex number a plus iota b, and similarly we take z2 as c plus iota d. So because the complex number is not given, we are taking any two complex number. So first of all, we taking left hand side z1 and z2 absolute. Now look here, we directly cannot take absolute. First of all, we require these two term products. Consider the terms z1 dot z2. First of all, we multiply to each other a plus iota b and to c plus iota d. Now multiply this one. It means that a is multiplied to both a into c plus iota d, plus similarly we multiply these iota b c plus iota d to both terms. Now open the brackets. A multiplied by c, we get ac iota AD plus iota BC plus iota square BD. Now simplify these two terms. AC plus, here iota is common, we can write AD plus BC, but here is iota square. We know that iota square is equal to -1. In the place of iota square we put -1. BD plus into minus minus, we can write AC minus BD, because these are the real part, plus iota AD plus BC. So this will be the real part Z1 and Z2, the product of Z1 and Z2. Now we are required conjugate absolute of z1, absolute of z1, z2, the product of these. So according to the definition of absolute, we can write first of all the formula a square plus b square square root. So here a is equal to ac minus bd whole square plus, and b will be as ad plus BC whole square root. So the first result we get this one. Now we can also open this term a minus b whole square, a plus b whole square. We can also open this term if you want to open this one. Now we are trying to solve z1 and z. We can open this one. We can write AC whole square plus BD whole square minus 2AB. Here AB is AC into BD. Similarly, we open this one AD whole square plus BC whole square plus 2AB square root. Now expand this term, we can write A square C square plus B square D square minus 2 ABCD plus A square D square plus B square C square plus 2 ABCD. Alphabetically we arrange these terms. A square root. Look here these two terms are cancelled to each other because one is negative, one is positive. A square C square, there is no term is available. Similarly, B square D square is not available. We can write these A square C square plus B square D square plus A square D square plus B square C square square root. Now we are giving first equation. We get taking right hand side is equal to z1 absolute and to z2 absolute. Now consider the term. First of all, consider the terms z1 absolute. First we find according to the formula absolute a square plus b square but here is also a square, and b square. Similarly, Z2 absolute we find a square plus b square, the general formula. But here is c square, we put c square, and here is d square square root. Now the product of these two terms Z1 and Z2 absolute product. So a square plus b square square root into c square plus d square square root. According to the property, if both terms are multiplied to each other, for example, x and y are multiplied. So according to the square root property, if both terms are multiplied, we can write in one square root. Similarly, here provided both terms are multiplied to each other, we can write in one term a square plus b square into c square plus d square and square root. Now we are simplified. A square is multiplied to these two terms. It means that here Z1 absolute and Z2 absolute result is coming here. A square c square plus d square. Similarly, we multiply this b square to both terms plus b square c square plus d square square root. Now multiply this one a square c square, a square d square plus b square c square plus b square d square. Now look here, if we check the comparison of this one, a square, but here is a square, b square is available. Arrange this term according to this. So we can write a square, c square, plus here is b square, d square is available. B square, d square, plus a square, d square, plus b square, c square, square root. Now give the equation number second, comparing of equation number first and second, we get the required result. Both results are equal. We can say that Z1 and dot Z2 absolute is equal to Z1 absolute into Z2 absolute. So both results are equal. Thank you very much for watching once again.